Welcome back for some more Euclidean geometry. This is the second last question on the November 2019 second paper mathematics. Question 9. Only question 10 to go after this. And the nice thing about question 9, there's only one question that we see there. So all we need to write down is question 9. Alright, so in the diagram, O is the center of the circle, ST is a tangent to the circle, M and P are points in the circle such that TM and MP are equal. So we see they've got little lines indicating that they are equal in length. And OT, OP, and TP are drawn. So OT, OP, and TP are drawn. And O1 is X. So that angle there is X. Let me write that down just in case you can't see properly. So that is angle X. Okay. Let's get into the question. So we have to prove that the following. We have to prove that angle STM, so angle T there, that is equal to a quarter X. Okay. So what we'll do is we'll start off by saying if this part is X, then this whole part must be 360 minus X. So we're going to say O2 equals 360 minus X, right? And our reason, so let's do this. Let's do a black line and then a reason in black. So the reason would be angle of a revolution, or angle, let's do angle of revolution. So that just means that a whole circle is 360 degrees. Okay, so that was the first part. Now, once we know that, we can see that this angle will be double this angle. So that angle will be half of this big one. So we can say that angle M, let's just do a cap for that one to show it's an angle as well. So angle M is equal to half of angle O2. So angle M is 360 minus X divided by 2. And our reason for that is, the name of that reason is just angle at circumference, so at the edge of the circle, equals the angle at the center, divided by 2. Okay, so angle at the circumference, M, is angle at the center, O2, divided by 2. Perfect. So far we have angle M. Now, we've seen that MP and MT, right, they're equal in length. This makes this an isosceles triangle. So let's just say that MPT is isosceles. Let's just write that down, isosceles, because MP and MT are equal. So what does this tell us? So that means that angle T2 is equal to angle P1. And what are they equal? They are, angles in a triangle add up to 180, right? So that means, well, let's isosceles. Yeah, that should be fine. That's a good enough reason. But let's maybe write it out. First write down that they are equal and then say the reason is isosceles, just to show all the reasons. So T2 equals P1, and the reason for that is isosceles. So MPT is isosceles. Alright, then we can say what they are equal to. So T2 equals P1 equals, and that'll be 180 minus M divided by 2. But we know what M is. M is 360 minus X. So that gives us 180 minus, and let's do that in pink just so we see what we're referencing, the 360 minus X over 2 over 2. Okay, let's calculate that. So we have 180 minus, and then 360 minus X over 2 is the same as saying 180 minus X over 2. Okay, or let's rather call it half x, because at the end we want something in the form of quarter x as well. So half x over 2, let's do some more calculations. So 180 minus 180 is nothing, and then negative half is positive half. So we've got a half x over 2, which gives us a quarter x. Okay, so we know that that is angle T2 and angle P1, but let's leave it at T2. That's more important for us now. Okay, so we've calculated T2 to be a quarter x. So that is a quarter x right there. Right, what else can we do? Oh, we can do T3. So let's do T3. Okay, T3, let's do that over here. So what will T3 be equal to? Well, we know that triangle OPQ is isosceles. So let's say T3 is equal to P2, and our reason again is isosceles triangle. So OPT is isosceles. And how can we know it's isosceles? Well, because that's a radius and that's a radius, and a radius is always the same length in the same circle. Okay, so what will each of those be equal to? Well, we do the same as we did in the previous part. We say 180 minus x. So let's do the T3 part, that's what we're interested in. So that's 180 minus x, our angle there, divided by 2 to give us T3 and P2 each. Okay, let's work that out. So that means that's equal to 90 minus half x. Okay, so this part here is 90 minus a half x. Good. We have a lot of angles so far. We're getting close. We're getting close. So we've got this angle, we've got this angle. Now we need to find T1, because that's our final one that we want, right? So how do we get that? Well, we know a tangent and a radius where they meet make 90 degrees. So this big whole T1 plus T2 plus T3 all together makes 90 degrees. Okay, so we're going to say STO, so that's the big T, equals 90, and our reason for that, 90 degrees, our reason for that is tangent and radius. Tangent is perpendicular to radius. That should be fine to say it just like that. Tangent perpendicular to radius. Okay, and what the rest that we want to do is we want to now calculate T1. So STM, which is what we want, equals angle T1, right? Angle T1, that little part. But we know STO equals 90. So T1, which we want, equals STO minus T2 minus T3. Okay, so T1 equals STO, which we said is 90, minus T2, which we see right here is a quarter x, minus, and T3, which we see there is 90 minus half x, Right, all we need to do is now calculate this. Okay, let's do this step by step. So 90 minus a quarter x, we can just write down, nothing to simplify there. And then we just multiply in the negative, so minus 90 plus half x. 90 minus 90 can cancel out. Oh, I wanted to do that in red, sorry. Can cancel out. And then we've got negative a quarter x plus half x. And what is a half minus a quarter? That is a quarter x. Perfect, and we're done with question 9. And now only question 10 to go. Join me again for that.